Hello my students in grade 6, this is Miss Mary and today is the first video in the fourth quarter. In this video we will start with lesson 4 in volume 2 about pure substances and mixtures. So let's start, and before we start I want you to open page 50 so we can solve the question in the book together. Okay, so let's start. First we will make introduction, and I want to remind you with what we have taken in the previous quarter, in quarter 3. What do your bed and water in the Gulf and air in your classroom they all have in common? All of them, they are examples of matter. They all have mass and volume. Matter is anything that has mass and takes up space. As we said before, like food, people, sand, books, all of them, they are examples of matter. What is atom? The atom is the smallest unit of an element. As we see here, we have a piece of aluminum. By using powerful microscopes, special kinds of microscope, we can see inside here the atoms. Can you see these tiny balls inside here? These are atoms. So what are atoms? Atoms are the smallest unit or the smallest particle, or the smallest pieces of an element or matter. If you divide something into smaller and smaller and smaller particles, you end up with an atom at the end. This diagram shows how atoms make up the piece of aluminum. So this piece of aluminum made of millions of atoms, as we see here in this picture. How can matter be classified? How can we sort matter or classify matter? We have three major classes of matter. We have three types of matter. Let's see them, like elements, compounds, and mixtures. In this video we will speak about elements and compounds, and we will speak about each one of them and explain exactly what does it mean. They all are made of atoms, but they are different in the way atoms are arranged and combined. So elements, compounds, and mixtures, all of them, they are made of atoms. But the difference between them that in each kind of matter, the atoms are arranged by different ways, and this is what we will see. Compare. This question, you have it in page 52, question 5, so please open page 52, question 5. And the question is, compare what do elements, compounds, and mixtures have in common. As I said before that, elements, compounds, and mixtures, because all of them are matter, all of them they have atoms. So the answer that we will write it down is they all are made of atoms. Okay, so we will go to the next part. Also in the book, page 53. Here we have the three types of matter: elements, compounds, and mixtures, and we will see the difference between them. In the first picture here, an atom is like a building block of matter. This is the atom, and the atom, as we said, it's like a block, one block. Okay, so when two atoms, they come together, they are the same kind, we call this element. So element is made up of one or more of the same kind of atoms. As we see here, they are the same kind, and they have between them a bond. They are attached together. Like here, the two pieces of the blocks, they are connected together, or they have bond between them. It's a little bit harder to take them away from each other because they have bond between. But in the elements, we have to know that they are the same kind of atoms. Atoms are the same. They have the same color. They have the same size. They are the same atoms. But in the compounds, a compound is made up of different kinds of atoms. As we see here, we have two atoms blue, and they represent hydrogen atoms, and we have one atom of oxygen. So when the two or more, they can be more, different atoms joined together by also chemical bond. In this case we call it compound. Like here we have one block red and two blocks blue. When they are connected together, or this is what means chemically combined. So connected together means chemically combined. When atoms chemically combined or attached to each other or connected to each other or bonded to each other, they form a compound. So the main difference between elements and compounds, that in elements atoms are, yes, the same, but in compounds atoms are different. This is the main difference between elements and compounds. In mixtures, the mixture contains a variety of elements, many elements together and compounds together, and they don't have chemical bond between them. They form a mixture. Like here, we have nitrogen alone, and water alone, and oxygen alone. They don't have any bonds between each other. The nitrogen doesn't have any bonds with water, and also oxygen doesn't have any bonds with water. In this case we call this a mixture, like exactly the fruit salad. If you're making a fruit salad, you put bananas, strawberries, apples, you put them together, you just mix them, but they don't combine together, they don't react together, they don't make new substance, right? So also here we have different types of matter, but they don't have chemical bond between them, they are just mixed together. Like here also, like the two blocks, here we have blocks yellow, and here we have blue and red. Here they have chemical bond, here they have chemical bond, but together, both of them together, they don't have chemical bond, they are just mixed together or put together in the same place. So the mixture contains variety of elements and compounds that are not combined. So please highlight this part with me, that in a mixture elements and compounds are not chemically combined, because in elements they are chemically combined, in compounds also atoms are chemically combined, but in the mixture again they are not chemically combined, and this is the main difference between elements, compounds, and mixtures. Let's solve question 7 together. Why are the spheres representing nitrogen and oxygen different colors? Why here we made the atoms of oxygen with red and the atoms of nitrogen yellow, and actually we can change any color, but the question here means why they are not all the same color? Because they represent two different types of atom. Nitrogen is totally different from oxygen. Both of them, they are gases, but every one of them has different properties, physical and chemical properties, because simply they are two different matter. So they are two different gases, and that's why we colored them with different colors. Here, the pure substances. We have two types of matter, the pure substance like elements and compounds. So pure, it means has only one kind of particles. They are made, as we said, of one type of particles. They have definite physical and chemical properties. The pure substance, you can know them easily from their properties and from physical or chemical properties. Like for example, the water is compound. Do you know that the water has melting point 0, has boiling point 100, has no color? Physical and chemical properties such as appearance, melting point, density, and we spoke about them in the last quarter. About physical and chemical properties. So here we have to know that pure substances, they have only one kind of particles inside. If they are elements, they are made of the same atoms. If they are compounds, they are made of the same molecule, and we will explain what means a molecule. They have definite physical and chemical properties. Each kind of elements have different properties, like gold has different properties than silver, than aluminum, than copper. Every one of them has different physical and chemical properties. Elements have only one kind of atoms. As we see here, we have here copper pennies, also like copper wires, Copper in general is an element. We bring it from the Earth's crust. The atoms that make up coppers are all the same. If you notice here, you will find that we have many atoms, and these atoms, they all are the same kind. They all are the same size. They all are the same color. They all are the same. So this is what's meant by element. Elements, as we said, has one kind of atoms. They combine together, but they all are the same. How many elements we have? Actually, we have more than 100 elements. And if you remember the last year, we took the periodic table where we arrange elements. There are more than 100 elements on Earth. Here we have some examples like the three major categories of elements: metals like lead, copper, and tin, and silver and gold. Many kinds of metals. As we know, metals are shiny, they conduct heat, they conduct electricity, they are malleable, easily bend. Non-metal are the opposite, like sulfur. We use sulfur in matchstick. We use it in many things. Iodine and neon, they all are examples of non-metals. They are not shiny, they don't conduct heat, they don't conduct electricity, they are brittle. Brittle, it means if you press on them, they easily breaks down to smaller flakes or pieces. Metalloids, actually they are between metals and non-metals, like boron, like silicon, like antimony. Actually, we don't have to know the names of these elements, but we have to know that we have different forms of elements, many kinds of elements, like here in the periodic table. Here I chose for you this picture for the periodic table because each icon from these icons, it shows how we use the element. Like here we have hydrogen that found inside the stars, if you remember. Also we have lithium, they use it in batteries, sodium in salt. Potassium, we get it from fruits and vegetables. We have the calcium as well. They found it in shells and bones. Let's go to the other side, like helium also here. They use it for balloons because it has low density, so the balloons go up. Neon, they use it for signs and lights. Argon, they use it for light bulbs. Sulfur here for eggs, if you see here. Phosphorus in bones. Silicon, they found it in stone and sand and soil. Aluminum, they use it for airplanes. So we have many kinds of pure elements everywhere. I just chose for you this picture for the periodic table to see that we have different types of elements, but we don't have to memorize each of them. Of course, we will not memorize all these elements. Okay, so now let's move to the next slide. Compounds. Compounds, they have two different kinds of atoms that combine chemically together, or they form bond together. Like here, we have the water here inside the ice, and also in the sea or in the ocean. Here, this is the water molecule. We call this molecule. Water molecule always have the same structure. What's mean molecule? Molecule, when atoms join together, they form a molecule. These